Hello friends, I am Jairaj Rathod, welcoming you in the session of point and slope form of equation of line. If we know about the slope of the line and point on the line, we can use m is equal to y minus y1 upon x minus x1 to find equation of line. Before we go for some example, we should recall the property of slope. So let's start with the definition of slope. Actually, slope is the inclination, or we can say tan of inclination of line L with positive x direction in anti-clockwise direction. Let's consider the line L. It has angle theta in anti-clockwise direction with positive x-axis. Then the slope of that line will be m is equal to tan theta. So this is the first useful formula to find the slope. Now the second one, if we have 2 points on the line, let's say x1 y1 and x2 y2, then we can use m is equal to difference of y upon difference of x to find the slope. And the third one is from the equation of line. Let's say general equation of line, which is ax plus by plus c is equal to 0. Then the slope of line is negative of a, which is coefficient of x, upon b, which is coefficient of y. So these are the three direct methods using which we can find out the slope. Now the fourth one and the important one is indirect method. Suppose we have another given line, let's say L2, and its slope is m2, right? And if we have angle between these two lines, actually active angle between these two lines is alpha, then using the formula of angle, tan alpha is equal to mod m1 minus m2 upon 1 plus m1 and 2, we can find out the slope of line L, let's say m1. Okay, and these are the special cases obtained from this formula are if two parallel line, given line and required line, are parallel to each other, then their slopes are equal to each other, and if they are perpendicular to each other, then the product of their slopes must be minus 1. Okay, so these are the formulas which are mostly useful to find the slope of line, and then we will go for the slope and point form of the equation of line. So recall this formula and get ready for some examples. You have to find the equation of line passing through 1, 2, 1 point, and slope m, which is 1 by 2. So first of all, let's collect the data for line L. x1 y1 is 1, 2, and slope is 1 by 2. So it's clear that we should use first form of equation of line, which is m is equal to y minus y1 upon x minus x1. We just have to put the values of m and x1 y1, right? So here we will get 1 by 2 is equal to y minus 2 and x minus 1, right? Okay, now to get the proper form of equation, we have to simplify. Let's cross multiply them. So x minus 1 banza will be x minus 1, and 2 into y minus 2 become 2y minus 4, right? So our equation of line will be x minus 2y plus 3 is equal to 0, which is your required equation of line. Ta-da! Now it's time to next question. And this question, we have to find the equation of line which is passing from 4, minus 6 and making an angle of 45 degree with positive x direction. This angle with positive x-axis is useful to get the slope. Here we have slope is equal to tan theta, where theta is angle with positive x-axis in anti-clockwise direction. So let's use this theta to get slope. Okay, m is equal to tan theta, or we can say tan 45 degree. We know that tan 45 is 1. So yippee, we get slope. We already have point, so it suggests that we should use first form of equation of line. Let's collect the data. Slope of line is 1 and it is passing from the point 4, minus 6. So this is the data, and the equation of line should be m is equal to y minus y1 upon x minus x1. We just have to put the data. M is 1, y minus y1 is minus 6 upon x minus x1 is 4. Let's cross multiply. X minus 4 is equal to y plus 6, or we can say x minus y minus 10 is equal to 0 is the required equation of line. Ta-da! Option A is your answer. In this question, we have to find the equation of line L, which is inclined at the angle of pi by 4 with x-axis. As we know, this angle will give us the slope using m is equal to tan theta, and it is passing through 1, 2. So this is our point x1, y1. Okay, now let's find out slope of line L, which is m is equal to tan theta, or we can say tan pi by 4. So finally we get m is equal to 1 by root 2, right? Okay, now it's time to collect the data for line L. It has slope of 1 by root 2 and it is passing from 1, 2. So we get our data of double underline, right? Which suggests that we have to use the slope point equation of line, right? Which is m is equal to y minus y1 upon x minus x1. Let's place the values of m, which is 1 by root 2, y1 is 2, and x1 is 1, right? Okay, now we know that we have to cross multiply to simplify this. X minus 1 ones are x minus 1, root 2, y minus 2s are root 2y minus 2 root 2, or we can say x minus root 2y minus 1 plus 2 root 2 is equal to 0. Ta-da! This is the required equation of line L. In our next question, we have to prove that the line passing through point x1, y1 and parallel to line L1, ax plus by plus c equal to 0 as the equation of a x minus x1 plus b y minus y1. Here, this parallel word is helpful for finding the slope, right? It is given that the line L1 as equation of ax plus by plus c equal to 0, and from the equation of line we can get the slope of the line, right? So let's call m1 is slope of the line L1 is minus a by b, right? Okay, now our required length L is parallel to L1, so we can say both slope will be equal, right? So our required line L has a slope minus a by b. Now let's collect the data for line L. It has slope of minus a by b and the point x1 y1. is itself x1 y1, right? So here we get our double underlined data, which suggests that we should use the first form of equation of line, which is m is equal to x minus y minus y minus y1 upon x minus x1, and we all know that slope is minus a by b. Okay, no problem. To get our final answer, we just have to cross multiply. So it will be minus a x minus x1 is equal to b into y minus y1. Let's rearrange the terms to get our final answer, and tada! Here we have our required equation of line, as we have to prove ax minus x1 plus by minus y1 equal to 0. In this question, we have to obtain the equation of line L is perpendicular to L1 line, which have equation 3x minus y plus 5 equal to 0. Gives that its x-intercept is 3, right? Okay, first of all, let's see the equation of L1 line, which is given line, right? To 3x minus y plus 5 equal to 0. From the equation of line L1, we can obtain the slope of it. So let's call its slope m1 is equal to minus a by b, where a is root 3, which is coefficient of x, and b is coefficient of y, which is minus 1, right? So let's place the value of a and b. So slope of L1 line will be root 3. Now it is given that our line L is perpendicular to L1. So the product of their slopes must be minus 1, right? Okay. Now m1 is root 3 and m2 we have to find, right? So we can say slope of our line L must be minus 1 by root 3, right? Now let's move to the second condition. The second condition is our line L as x-intercept is 3. That means it is passing from 3, 0 point, right? Okay, so let's collect the data. Line L has slope of minus 1 by root 3 and it is passing from 3, 0, right? Finally, we get our double underlined data, which suggests that we should use the first form of equation of line, which is m is equal to y minus y1 upon x minus x1. Let's put the data. M is minus 1 upon root 3, y1 is 0, x1 is 3. Let's cross multiply. Minus x plus 3 is equal to root 3y. Or we can say x plus root 3y minus 3 is equal to 0 will be your required equation of line. Ta-da! In this question, we have one triangle having vertices A, B and C. The coordinates are minus 1, 5, 0, 0 and 2. So first of all, let's draw the triangle. Here it is. Okay. Now, D is the midpoint of BC. D is the midpoint of BC. Okay. Now, we have to find the equation perpendicular to B. perpendicular draw from the B to the line AD. So first of all, let's draw line AD, and then we have to draw line passing from the B and perpendicular to AD. It will be something like this. So actually we have to find the line L. We already have the point B on the line, right? We just need the slope, and this perpendicular word will helpful to get the slope, right? Okay. So first of all, let's find out point P, then find the slope of AD, and it will helpful to get the slope of L, right? Let's do as we plan. First of all, midpoint of AB, BC. B is summation of x coordinate by 2 and summation of y coordinate by 2. So plus by 2. Okay. Or we can say the coordinate of D is 1, 1. Now the second step, find out the slope of AD. Okay. Let's find out slope of AD line. We know that coordinate of A is minus 1, 5. Coordinate of B is 1, 1, which we find, right? Let's call M1 is the slope of AD. We will use the second formula, difference of y upon difference of x, right? So 5 minus 1 upon minus 1 minus 1, or we will get 4 by minus 2. So the slope of AD is minus 2, right? Now slope of AD will helpful to find the slope of our required line M. Let's call it M2. Now we know that AD is perpendicular to L. That's why we can say product of the slope must be minus 1. So M1 must be minus 1 upon M2, or we can say 1 by 2, right? Okay. So we get the slope of the line L, and we already have the point on the slope, right? So we just use point slope method of the equation of line, right? Okay. First of all, let's write down the data. The slope of L is 1 by 2. The point on the line is 0, 0, right? So we will use point slope form. Just put the data. 1 by 2 is equal to y minus y coordinate of the point and x minus x coordinate of the point. So we can say y is equal to 2x. Oh, sorry. X is equal to 2y. That means x minus 2y is equal to 0 is the required equation. L. Ta-da! Option C will be your correct answer. In this question, the equation of line passing through 3, minus 2. So we already have the point. Inclination of 60 degree with the another line root 3x plus y equal to 1. So basically one line L1 is given, and we have to find the equation of another line. Okay. So using this inclination, we can find out the slope of the required line, right? Okay. And for that we are going to need the slope of L1 line. Okay. Now we already have the equation of L1 line, root 3x plus y equal to 1. So we can say from the equation of line, we can find out slope of the line L1, right? Let's call it M1 minus coefficient of x upon coefficient of y. Coefficient of x is root 3 and coefficient of y is 1. The slope of the line L1 is minus root 3. Okay. Now it's time to use the inclination. Okay. Let's assume that slope of line L2 is M2, right? So using the formula of inclination, tan alpha is equal to M1 minus M2 upon 1 plus M1 into M2. Put the data. What we have? We have tan 60 degree is equal to slope m1 is minus root 3 minus m2 upon 1 plus m1 is minus root 3, so it will become root 3 m2. Okay, and we know the value of tan 60. Tan 60 is actually is root 3. Okay, now this is the important step. Whenever you remove the mode, you will get two options. First one, plus root 3, and the second option is minus root 3. Okay, so now we have to simplify these two possibilities to get the value of m2. Okay, let's do it. Cross multiply, we will get minus root 3 minus m2 is equal to 1s are root 3 and root 3 will become 3m2. Okay, let's take 3m2 on the left side. So we will get 3m2 minus m2 is equal to plus root 3. So here we will get 2m2 is equal to 2 root 3. Or we can say slope of the line L2 is root 3. Now let's do the same thing with the another option. So you will get minus root 3 minus m2 is equal to minus root 3. Root 3 will cancel out and we will get actually 4m2 is equal to 0, or we can say m2 is equal to 0, right? Okay, so here we get two different slopes, so we will get two different equation of L2. Now let's take the first option, m is equal to root 3, and we already know that equation line L2 is passing from 3 comma minus, right? Let's use that point for the point slope method. Here we have point slope equation. Just put the data. M is root 3. Y minus y coordinate is minus 2. X minus x coordinate is 3. Let's cross multiply. So we will get root 3x minus y is equal to 2 plus 3 root 3. It's the first equation of line. Now we also have to find another equation for the second option, which slope is 0 but point is still same, comma minus 2, right? So let's use again point slope equation. Put the equation put the slope values. Slope is 0 is y minus y coordinate is minus 2 upon x minus x coordinate is 3. So finally we will get y is equal to minus 2. Ta-da! We have two equations of required line. First one is root 3x minus y is equal to 2 plus 3 root 3, and another is y is equal to minus 2. Let's see the option. Oh yes, option A is the right answer. Our next question contains one triangle. If midpoint of BC, CA and AB is, let's call it P, Q and R respectively, then we have to find equation of side AB. First of all, let's draw a triangle. Here we have triangle A, B and C, and we have midpoints of BC, P, Q, R. Their coordinates are 1, 3, 5, 7 and minus. We have to find equation of AB line. You can say AB line is passing from the point R, right? So we already get the point. Now we just need to get the slope. Actually, AB line is parallel to PQ, right? So this parallel condition will helpful to find the. First of all, we have to find of PQ, and for that we are going to use the coordinates of P and Q. Problem. Let's call slope is m. It's just a difference of y upon difference of x. So y 3 minus 7 and difference of x 1 minus 5. we are going to get minus 4 upon minus 4, or we can say 1. Now, as we suggest, PQ line is parallel to AB line. So we can say slope of PQ is equal to slope of AB, right? We got the information about the AB. For AB line, its slope M is equal to slope of PQ, which is 1. And AB is passing from the point R, which have coordinates of minus 5, 7, right? Here we get our double underline data. Now we just have to use slope point form of the equation of line, right? Here it is. Now we just have to put the value and simplify it. Our slope is 1, then y minus y1 is 7 upon x minus x1 is minus 5. Let's simplify. X plus 5 is y minus 7, or we can say x minus y plus 13 is equal, 20 is equal to 0 is the required equation of line AB. Ta-da! Let's see the next question. We have to find equation of line, which first one, bisect the line joining 2 point A and B, and second condition is perpendicular to line joining C and D. Okay, let's deal them one by one. The first condition is line L must be bisect the point AB. That means line must be passing from the midpoint of A and B. Okay, so that point is important for us. Let's find out midpoint, and it's called x1 y1. Okay, so summation of x coordinate by 2 and summation of y coordinate by 2. So we will get the point 4 comma minus 1. Okay, so first condition is useful to get the 1 point. Okay, now let's move to the second condition. In second condition, it is given that the line is perpendicular to point CD. So the perpendicular word will suggest that we should find out the slope. Okay, so let's get the slope of CD. Okay, here we have the coordinates of C and D. So let's use the second formula of the slope. Slope of CD, let's call it M1, is the difference of y, 3 minus minus 1, upon difference of x, 5 minus minus 1. So here we will get, minus 1 minus 5. So slope of this CD will be 4 upon minus 6, or we can say minus 2 by 3. Okay, now we know that L is perpendicular to CD, so M1 into M2, which is the slope of L, must be minus 1, or we can say M2 must be minus 1 upon minus 1 upon M1. So M2 must be 3 by 2, right? Okay, so finally we get the point and the slope, which suggests that we should use first form of equation of line, which is M is equal to y minus y1 upon x minus x1, right? Okay, let's collect the data about the L. Its slope is 3 by 2, and the point from which it is passing from is 4 comma minus 9, right? So we are ready to use the formula. We just have to put the values of M, x1, y1. Okay, so here we will get 3 by 2 is equal to y minus y1 upon x minus x1, or we can say, let's simplify, or we can say cross multiply. 3x minus 12 is equal to 2y plus 18, or we can say we will get 3x minus 2y minus 30 is equal to 0. Ta-da! this is the required equation of line. Let's see the option. Yes, option A is the correct answer. Let's see the next question. If coordinate of A and B 1 1 and 5 7, then the equation of perpendicular bisector of the line segment AB is dash. Actually, we have to find perpendicular bisector. First of all, I would like to introduce you the properties of perpendicular bisector. I know તમને યાદ જ છે, પણ તો બી એક વખત ફરી સમજાવી દો તો સારું રહેશે. It is made up of two terms, perpendicular and bisector. Perpendicular means our line is perpendicular to AB, so it will helpful to find out the slope. And bisector, that means it will passing from the midpoint of A and B, so we should find out midpoint of A and B, right? Okay, so let's do this one by one. First of all, let's find out the slope, and for that we are going to need slope of AB, right? So here we have coordinates of A and B. So here we have the formula of the slope. We can take difference of y upon difference of x. So let's find out slope of AB. Let's call it m1. So difference of y, 7 minus 1 will be 6 and 5 minus 1 will be 4, or we can say 3 by 2 is the slope of AB, sorry. So let's assume slope of L is m2, and we know that L is perpendicular to AB. So we can say m1 into m2 should be minus 1, or we can say m2 must be minus 1 upon m1. So yes, we get the slope minus 2 3. Now it's time to get the midpoint. Okay, no problem. Midpoint can be easily find out using the coordinates of A and B. Just add the x coordinate and divide it by 2, and summation of y coordinate divided by 2. So tada, we get the midpoint. 5 plus 1, 6 by 2, 3. Okay, now using the slope and point, we can find out equation of the line using slope point form, right? Okay, so first of all, let's collect the data about the L, which we already find out. Slope m is minus 2 by 3, and it is passing from the point x1 y1 is 3 comma 4. Okay, so we just have to use the formula of slope point form, and here it is. Let's put the data. Slope is minus 2 by 3, and y minus y1 is 4 upon x minus x1 is 3, right? Okay, let's cross multiply. So we will get minus 2x plus 6 is equal to 3y minus 12, or we can say 2x plus 3y minus 18 is equal to 0 is the required perpendicular bisector. Ta-da! Option A is the right answer. Okay, here we have very important and interesting question. We have to prove that the line which is perpendicular to L1 line x sec theta plus y cosec theta equal to A, and passing through this complicated point A cos cube theta and A sin cube theta is x cos theta minus y sin theta is equal to A cos square minus sin square theta. So basically we have to find the equation of line L, right, which is perpendicular to L1 and passing from this point. Okay, we already done this type of questions, right? This perpendicular word will helpful to get the slope using the property of perpendicular line, that product of their slopes must be minus 1, and slope point form will be the equation of line, right? Okay, so first of all we have to find the slope of L1 line, which is x sec theta plus y cosec theta is equal to a, or we can say minus a equal to 0, right? Okay, if we compare with the standard equation, we will get cosec theta as the a of L1, and sec theta will be a and cosec theta will be b, right? Okay, so let's use slope of L1 m1 is minus a by b, or we can say minus sec theta upon cosec theta. It is preferable to convert this sec and cosec into sine and cos form, because we need the equation of line in form of sine and cos, right? So m1 must be equal to minus sine theta upon cos theta. Okay, now our required line L is perpendicular to L1. So if we assume that slope of L is m, then product of slopes must be minus 1, or we can say m must be minus 1 upon m1. So slope of line L will be cos theta upon sine theta. Yay! For line L, we get the slope m is equal to cos theta upon sine theta, and we already have the point on the line as a cos cube theta and a sine cube theta, right? So now we have our double underlined data, which suggests that we should use slope point form of equation of line, which is m is equal to y minus y1 upon x minus x1, right? We just have to place the values of m and x1 y1. Okay, no problem. Let's put the value of m, which is cos theta upon sine theta, and y minus y1, which is a sine cube theta upon x minus x1, a cos cube theta. To get our final answer, we have to simplify it. Let's cross multiply. Cosec theta x cosec theta x minus a cos cube into cos will increase 1 power of cos raised to 4 theta is equal to sine theta into y will be sine theta into y minus a sine raised to 4 theta, right? Okay, let's rearrange the terms. Cos theta x minus sine theta y equal to a cos raised to 4 theta minus a sine raised to 4 theta. We almost there. Let's a common and use the formula of a square minus b square, which is a minus b and a plus b. So let's write a minus b and a plus b, and we all know that cos square theta plus sine square theta is 1. So tada, we almost have our final answer. So friends, here we are in the end of the video, but I must say your practice session is not over yet. Hope you enjoy, but still you have to practice for better grip. If you have any doubt or query or suggestion, feel free in the comment section box. So bye bye, take care and Jai Mataji.